it is communication system. So in this communication system, we are first studying about the elements of communication system, what and all a communication system is going to have, and what kind of system you'll call it as a communication system. It might be a wired communication or wireless communication, but the general structure will be like this only. Whether you are using a landline, or you are using a computer, or you are using a mobile or anything, but the overall structure will be like this, and this blocks will be general, or it is they are the mandatory blocks in all the communication systems. So here the first thing is information source. So information source means, the first of all, what is communication? So communication is the exchange of information between 2 points. So without having any 2 points, you cannot have any communication. For communication to happen, at least you need to have any 2 points where you can exchange the information. So person A and person B should be there. You cannot call, if you have only person A and we tell that he is communicating, that is not possible. There should be a sender and there should be a listener or a receiver, then only the communication can happen. So communication is the exchange of information between 2 points. In this communication system, first part what we are having is information source. Information source means it can be any type of information, like it might be an image or text, voice, video, etc. It can be any type of information that can be sent. So and source will be different. Suppose if you take, um, I'm the I'm at the sender part. So I'm speaking. So here I have a mic through which my sound is my voice is getting captured and it is going to be transmitted. So now the source is myself. I am the source where the information is generating. This information source will be myself as of now. Suppose you are texting someone, so your mobile will be the information source where you are texting, or you have captured an live video and you are streaming it, so your camera will be the source. So like that. So this is the first part, and this information source, it will be different at different situation and different application. So that's why we tell source might be anything, and information might be image, text, voice, video, etc. Any type of information that can be there. Source is the one which is producing it. So once the source is going to produce the information, it will be sent to input transducer. Transducer, the other synonym for transducer is sensor. As I told, I have a mic. So mic is a transducer because it is capturing my voice signal, which is in the form of a sound, and it is going to convert that into electrical signal. So the device which converts one form of signal to another form of a signal is known as transducer. So in general way, we call it as a sensor. Sensor is one which senses any information and it gives out in another form. Since we are using the electronic systems, so the sound signal will be processed in the form of electrical signal. So the mic, whatever I'm using, that is a transducer which converts the sound signal to electrical signal. Even you might capture a video from a camera and you want to transmit it, there also will be using transducer which converts that video to electrical signal. Everything should be processed in the form of electrical signal. So transducer is one of the major part. This transducer signal, so finally it will be converted into the form of a signal. It might be in any digital form, but finally it will be converted into a analog form. Now we are having a modulator and a transmitter. Now the question is, why we need this modulator? So modulator is a device which is going to add some carrier signal to the message signal. See, whatever the information which was generated, that is a message. See, I'm talking, this is the message. We call whatever the signal I'm producing, no, that signal is known as message signal. This is message signal. It should be transmitted for a longer distance. You are sitting at a longer at a far distance. Someone is sitting in Bangalore, someone is sitting in other places, Delhi or etc. So this signal has to be transmitted to that level, to that distance. So if I want to transmit my signal alone, my voice signal alone, it is not possible, because whatever the signal we are producing, uh, that is not having much energy. Because when you represent a signal, this signal will be represented in the form of the voltage versus time. Usually what happens is, when the is transmitted in the air, as it starts passing in the air, its signal's amplitude, that is voltage, start reducing, and finally it will be zero. That's why when if you take an example of a classroom, if a teacher is standing here and he is teaching, the students who are sitting in the first bench will be listening to that voice with a louder sound. The students who are sitting at the last bench will be listening to that voice with a lesser sound, because the sound, the signals or the sounds energy starts decreasing with respect to time or with respect to distance. So when the signal was given out, these persons are sitting very close to the teacher, so they can listen at the same volume. But these students are sitting at the last bench. So by the time it reaches here, the volume or the amplitude of the sound starts decreasing. Energy of the signal start decreasing. So in the class itself, we are facing this issue. If you want to transmit the signal for a far distance, which are in hundreds, thousands of kilometers far. So in that cases, we cannot send the message signal alone, because its strength is very, very less. And as you know that our audibility range itself is maximum 20 kilohertz. So obviously the sound, whatever we produce, should be within that range only. We cannot increase our frequency because we are having some limitations. So that's why what we will be doing is, we'll use a device called a modulator. This modulator is going to generate a signal called carrier signal. So this carrier signal will be of high frequency, high voltage, that is amplitude. So when signal is having high frequency and high voltage, that signal can transmit for very far distances, like hundreds or thousands of kilometer also. That's why what we do is, we are going to mix this message signal to this carrier signal, and we are going to have a modulated signal. The mixing of message and carrier will give you a modulating signal. That modulating signal will be transmitted to the receiver side, so that our message signals energy will not reduce. If there is any reduction, the carrier signals energy will be reduced, but our message signal will be safe. It is just like we are moving in a vehicle. So let us assume that we want to travel from Yelahanka to some electronic city. So what we do, we book a cab and we sit in the cab, and the cab moves to electronic city, right? So the cab's energy will be reducing. That means, because of the diesel which is giving energy for that cab might be reducing, but our energy will be as it is. Slightly we might have some, we might lose small amount of energy, but we'll not have that much of physical stress. If you want to walk from Yelahanka to electronic city, you will be fully strained out. So, and you lose complete energy. That is very difficult to walk, right? So we sit in a cab and we'll move. That cab is carrier signal, we are message signal. So this kind of modulation is known as this kind of technique is known as modulation. Now, just at least reply to this. Say we are sitting in a cab, right? So now, just tell me, we are going to customize the cab's location, cab's travel direction, or we'll simply sit in the cab and wherever the cab goes, we'll go. Hmm?
So we
I'll
will
repeat that.
we select the location.
We select the location and we'll customize the that cab, right? In the location, everything, and the traveling path, everything we customize it based upon our requirement, right? That's what I wanted to tell. We want to travel, so what we will do, we will choose which is convenient for us and which route is easy for us. Based upon that, we are going to, we will not just simply get into a bus and we'll sit. We will choose, and that route will be customized according to our requirements, then only we'll travel. Okay. And one more thing, see, we are traveling from Elanka and to Electronic City. After traveling to Electronic City, let us assume that your house is at Electronic City. So you'll get on at your house. Will you take that cab inside your house? What you will do with that cab? Hmm? Only you will get into your house, or you'll take the cab along with you. Hmm? What you will do? It is simple common sense question I'm asking.
So only we will go. So,
Only we'll go, right? The cab is going to travel wherever it goes. In the same way, here to the message signal, we will generate a carrier signal and we will add this message signal is added with a carrier signal. At the receiver side, we are having a demodulator which is going to work in reverse direction or in a reverse manner compared to modulator. What it is going to do is, from the incoming signal, it is going to remove the carrier signal and it will take only the message signal. How we did here, no? We went over place and we got down. So after that, the cab left. We don't worry. Will you worry that where the cab went, all these things? We don't worry, right? We have reached the destination, done. We don't worry about the cab. In the same way here, when we reach the destination, when the signal is reaching the destination, demodulator is going to take only the message signal and it will ignore the carrier signal and it will be discarded, and we will be getting only the required message signal. So this is what the technique of modulation and demodulation. Okay, so coming to this, so transducer, after transducer, we are getting an electrical signal. To that electrical signal, this modulator is going to add a carrier signal. So to generate that carrier signal, it will be having an oscillator that we'll study in module 4, what is oscillator and all. In general, oscillator means it is a device which is going to generate oscillation or which is going to generate signals of any desired frequency. So this carrier signal will be of very high frequency and high voltage. Why we need high frequency, high voltage? Just coming back to this example, you are getting into cab. Whether your weight is more or cab's weight is more. Hmm?
Cab's weight.
Cab's weight, right? Obviously, if your weight is more, how the cab can carry you? So obviously, it will be having very higher weight. The mass of the cab will be more compared to us, right? So in the same way here, the carrier signal will be of very high frequency, high voltage or amplitude. To this, message signal will be mixed and that will be fed using transmitter. We'll be feeding it to the channel. So channel might be, it might be wired or wireless. So if you take wired channel, nowadays we are using optical fiber cable. As you know that optical fiber cables means they are going to work on the principle of what? How the signal transmits in the optical fibers
Total
TIR,
internal reflection.
reflection.
in
Total internal reflection.
Yes, total internal reflection TIR. So the electrical signal will be converted to light signal, and that light signal will be having multiple reflection that we call it as TIR, and it reaches the destination. At the destination again will be having a detector. Detector is nothing but the receiver. It is going to convert back that light signal to electrical signal, and from that electrical signal it is going to remove the carrier, and it is going to give the message signal, and finally we are going to give it to the speaker. So speaker is going to produce whatever the sound which was sent here. Okay, in between this channel some noise will get added up because of any distortion or because of any the wire might be having um, some damages, or suppose if you are going for wireless also some other frequency signals might join our signal. So because of that slight noise will be there. So for that also we'll be in higher versions, a higher level of studies, we'll discuss about how the noise is removed and all. But for your thing, channel will be there. To that channel a noise will be added. See, we are not going to add, automatically that noise will get added up, and that signal is going to reach. Now, can you tell me one thing? I was telling about OFC, no? And we have studied some diodes in module 1. Can you tell me what kind of diode I can use here and what kind of diode I can use here? And even while doing module 1 also I had told the same example, I guess. Just think what kind of diode you want to convert this electrical signal to light signal, and again from light signal to electrical signal. Some diodes we had studied in module 1 in semiconductor.
Sir, photodiode and LED.
Where you'll use LED, where you'll use photodiode.
At the transmitting end, photodiode, and then later end, LED.
Is it? What does it LED will do? Just think.
From electrical signal to light.
Hmm. So if you use that at the receiver side, what is the use? Your answer is correct, but positioning of the diodes is you're messing up. See, of OFC means in the channel, signal is in the light form. Signal is traveling in the light form, in the form of a light.
So then transmitting end LED, the receiver end photodiode.
Yes, very good. So in the if you are using wired channel, then at the transmitting end we'll be using LED because it converts electrical signal to light signal. At the receiver side, we are going to use photodiode, which converts light signal back to electrical signal. Okay, so this is the process, or this is the brief description of the elements of communication system. So noise might be because of some lightning, or in the rainy season because we'll have some distractions and all this, because signal cannot travel easily. That's why you might have observed if you are using DTH at your house, whenever there is a heavy rain. So sometimes the DTH will not work, the signal will not be catched because the signal will get distracted, because from the broadcasting station the signal will be broadcasted, and the antenna what we are putting at the top of our house, that has to capture that signal. But when there is a heavy rain, our DTH antenna will be not capable of receiving it, because the signal will get distorted. So that is what noise means. So another time we'll be getting the channels by using DTH with a very high clarity and all. So this kind of distortion even occurs in the wireless channel also. In wired channel also, there might be some patches somewhere. Because of that, the light penetration might leak out somewhere like that. Because of that, the signal may not transmit, or there might be some tapping of the signal, or some additional signals might join this light signal like that. So there might be some kind of noise that can be added. See, noise means it is unwanted signal. See, let us assume that me along with someone, we are talking. Some person will take Shripad. Me and Shripad, we are talking together. So some other person starts talking. For us, that other person's voice is a noise. Okay. So any unwanted signal is a noise. It doesn't mean that noise means it should be like somewhat irritating sound. It can be any signal which is unwanted is a noise. Okay, so the whenever it happens even in our GSM also, no, whatever we are using, sometimes there will be cross connections, and we'll be talking, some other person will also be talking, and we'll listen to that person voice also. That is a noise for us. That happens because of the cross connections and all. So that kind of noise can be added up. Okay, this is about the communication system. So after this communication system, we need to discuss about what is the need of modulation and what is this modulation actually. So modulation, as I told, in the modulation part, we are going to change the parameter of the carrier signal in accordance with the message signal. As I told, we customize the route of the cab based upon our requirement. So modulation, it is the process in which carrier signal is varied in accordance with the message signal. So based upon the message signal, the carrier signal will be modulated. So here in modulation, we are having three types: AM, FM, PM. AM means amplitude modulation, amplitude modulation. FM means frequency modulation, and PM means phase modulation. Can anyone tell me among these three which modulations you have seen? Maybe in your car or anywhere. When you switch on your music system, among these three,
FMs.
FM and
only
AM.
FM, AM,
AM.
only FM. Even AM is
AM.
also there, right?
Yes, sir.
Sometimes you can see AM also. AM is not that much widely used. FM is widely used, but AM is also existing. Even AM stations are also there. Okay, you can see in your car music systems and all, AM option will be there. So you can get AM stations also, but AM stations are very, very less. We use FM stations. So these two stations we can see, but FM is widely used. Let us see what is amplitude modulation first. Say amplitude modulation means the amplitude of the carrier signal is varied in accordance with message signal. So if you, let us take, this is a message signal and we are having a carrier signal like this. One common sense question I'm asking you, among these two, which is having higher frequency, and how you are going to tell it is having higher frequency? And this is the message signal and this is the carrier signal. Among these two, which is having higher frequency?
Carriers.
Carrier. How you are telling it is carrier?
Number of cycles per second is higher.
Good. Number of cycles per second is higher. So this is having higher frequency. Or in another way, you can tell that T is equal to 1 by F. F is equal to 1 by T. You just see this is one cycle, right? From here to here. This is one cycle. Time period of this one cycle, and you just check with the time period of this. Whose time period is more? Message or carrier's time period?
Message.
Message. Lesser the time period, what will be more?
Message.
No,
Frequency.
lesser the time period, frequency will be more, right? So in that basis, we can tell carrier signal is having higher frequency. See, whenever signals are very closer to each other, cycles are closer to each other, that indicates it has higher frequency. Whenever the signals are at farther distance, then that indicates it is of less frequency. Lesser frequency signals will be having wide time band, but a higher frequency signal will be very closer to each other. So these are the things, because in your next lab practicals and all, you will observe these things. Okay. Now, as I was telling about amplitude modulation, when I combine these two and I apply amplitude modulation technique, the signal will become like this. The signal will become like this. So can you tell me now, in this case, you can easily observe this is our carrier signal. Carrier signals frequency is changed or its amplitude is changed. See here, amplitude is almost same. The amplitude means voltage. It is almost same. But what has happened here? See the amplitude levels. What is modulated in this? What part of carrier is modulated?
Amplitude.
Amplitude, right? So there are, when you when you represent a signal, there are some parameters. One is amplitude. Amplitude is nothing but voltage. Other one is frequency, time, phase. These are the parameters that describe a signal. So in this part, you can see that almost the frequency, the signals, the time period or the frequency of the signals are almost same, but its amplitude is varied. This kind of modulation, where amplitude of the carrier signal is varied in accordance with the message signal. So this amplitudes, the amplitude of this carrier is varied in accordance with the message signal amplitude. This kind of modulation is known as amplitude modulation. So variation of the amplitude of the carrier signal in accordance with the message signal, keeping phase and frequency constant, is known as amplitude modulation. So here only the amplitude is changed, its angle or its phase or frequency is not changed. This kind of modulation is known as amplitude modulation. Next, uh, if you are going for FM, then again we'll take one more carrier signal. We have a carrier signal like this. So in FM, what happens is instead of amplitude, the frequency of the carrier signal is varied in accordance with the message signal, keeping amplitude and phase constant. That will not be changed. So here what happens is during positive half cycle, the signals will be very closer to each other. During till here, during positive half cycle, that portion, the signal will be very closer to each other. During negative half cycle, the signal will be like this. This indicates we have used FM, frequency modulation. So frequency of the carrier is varied in accordance with the message signal, keeping the amplitude and phase constant. You can see that whatever the amplitude we had here, here also we are having same amplitude. And its phase is not changing. It is continuously like this. Phase changing, I'll tell you next. But here only the frequency is changing. So this type of modulation is known as frequency modulation. Coming to phase modulation, here we are going to change the frequency. Frequency of the carrier is where carrier signal is phase modulation we are doing. So phase of the carrier signal is varied in accordance with the message signal, keeping frequency and amplitude constant. So here what happens is the signal will be as it is like this. Okay, this is the message signal. I have redrawn it. Okay, signal will be as it is, but at this, when the negative half cycle comes, there is a phase shift. There is a phase shift. Again, if you continue the signal, let us assume, again here there will be phase shift. Here, when positive to negative it is going, there will be a phase shift. So when you take these two signals, this signal and this signal, what do you observe in these two? Here, between these two cycles, they are having a phase difference of 180 degree, because when the cycle is moving like this, the next cycle has to start from the negative, but it is starting from positive. So we tell that this cycle and this cycle are having a phase difference of 180 degree. So here we are changing the phase of the signal. Phase means angle of the signal. So changing the phase of the carrier in accordance with a message signal, keeping frequency and amplitude constant, is known as phase modulation. In phase modulation, we are not going to change the frequency, we are not going to change the amplitude of the carrier. We just change the angle. So wherever it is shifting from positive to negative or negative to positive, the phase will shift. This kind of modulation is known as phase modulation. So for your syllabus, you have only its definition. We will not go in detail. That is no derivations and all. So even though we are having these three type of modulation, they are having their own limitations. That's why few of them are used widely and some of them are not used. See, in frequency modulation, it is having a wide bandwidth, and in frequency modulation, it is easy to tune the signal. Basically, what we want is we need a wide bandwidth. See, bandwidth means it is in terms of frequency. See, we can have frequency of of a very higher range, right? Starting from hertz to gigahertz, we can have, or still higher values also we can at terahertz we can have. Terahertz frequencies are also there, right? 10 to the power of 12. But can you have an amplitude gigavolt? Is it possible to have gigavolt? Hmm?
No, sir.
Gigavolt means how much? 10 to the power of 9 volt. Is it possible to have that much higher voltage? It is not at all possible. Because maximum we for industrial purpose we use 1000 volts. Okay, for household purpose we use 230 volts, 240 volts. For industry purpose we use 1000 volt. That is also, that should be used at a very high care. So that's why they are going to divide it. So that's why for industries they allot a particular area, because there for they need to supply, they need a higher voltage supply. For domestic purpose they need lower voltage supply. That's why we tell residential areas they are all industrial areas. In industrial areas they'll give 1000 volt supply. In domestic areas they'll give 230 volt supply. So when you want to use amplitude modulation, you cannot have much changes, because we are having only limited range, and also you cannot even transmit 230 volts signal, right? In air, if you are transmitting 230 volt signal, what will happen? It is not possible. Maximum you can transmit of 5 volt in the air. 5 volt signal that can be transmitted in the air. So even that is not allowed. So that's why when you go near a petrol bunk, usually they'll tell no, don't use mobile. Do you know the reason why? Hmm? What is the reason? When you go for a petrol bunk, they'll tell don't use mobile. Why is that? Because the signals which are traveling, no, they'll be having higher energy. There is some rules and regulations made by government, that the signal should not cross this. But what happens is some companies, private companies, private network providers like Airtel or Jio and all. So what they'll do is to increase the quality of their signal, they will give more energy to that signal. Actually, the signal transmission voltage should be very, very less, like 1 volt or 1.5, 2 volts. That's it. But to give more quality, what they'll do is they'll amplify that signal to a higher voltage and they'll transmit. And whenever you are near a petrol bunk, during that time, if someone is going to call you, so automatically that signal is going to connect to your mobile. So when that signal hits your mobile, obviously it is going to hit the petrol bunk, that device also. So automatically it catches fire. That's why they tell don't use mobiles. Okay, so amplitude modulation is not so easy to use and not so easy to modulate, but amplitude modulation is mainly used in military applications. It is mainly used in military application because it is quite difficult to uh, trace it. So basically amplitude modulation is used in military application, and also in commercial applications also we are using, but we don't have much stations. Coming to the frequency modulation, this frequency modulation, as you know that we are having wide range of frequencies. We can use any range of frequencies, and we can easily access it. So we can tune the frequency as whatever we wish. And also you know that frequency spectrum, that is very, very important. So because based upon the frequency bandwidth whatever is allocated to you, that many number of persons can be allocated, that many number of persons can access the channel. So that's why when they bid in the government sectors when they bid for in the telecom industry for frequency spectrum and all. There'll be huge scams and all. You have heard about news in spectrum scam and all, because that is very very costlier. Every companies want to get more spectrum, more frequency band. So based upon that, if they have more frequency range, so they can accommodate more number of persons, more number of customers, subscribers. If they have less frequency bandwidth, they can accommodate only less number of subscribers. That's why this private companies and all, no, they try to acquire more spectrum. That's why it is they bid and it is very costlier. Coming to phase modulation, this is not used in a commercial aspects. They'll be using it in internally or to just provide a security purpose. Okay, this is about the AM, FM, PM. Some things I have told just for general idea, but just you need to know what is AM, FM, and PM. So after this, uh, we are having the next topic, need of modulation. Why do we need this modulation? So need of modulation, we are having mainly 5 points to reduce the height of antenna. Next one, to avoid mixing of signals, to increase range of communication. Next, to allow multiplexing of signal, to allow adjustment in bandwidth, and to improve quality of reception. So these are all the reasons why for which we go for modulation. First thing is to reduce the height of the antenna. See, height of the antenna. See, antenna usually, see, now also. Where do you put DTH antenna? Will you put at the ground or at the top of the building or inside your house?
Top of the building.
Top of the building, right? Because it can catch the signal. So higher the height of the antenna, more quality signal will be caught. But if you are not using modulation, in the sense, we are not mixing carrier signal with a message signal. We are just transmitting a message signal. So if you are just transmitting the message signal, then if you want to capture that message signal successfully, then the height of that antenna should be very, very, very high. Because there is a lot of distraction. See, even when we speak out, if there is something in front of us, that our signal is going to hit that. Because of that, what happens? Multiple reflection happens. Because of that, the signal strength reduces. So we have a lot of such problems. That's why if your the wall of the building is very, very thicker, the signal cannot penetrate. That's why we'll tell, oh, we are not getting signal inside, because the walls, because of multiple reflections, the signal cannot penetrate inside. So we have a lot of such things. But in that situation, if you're transmitting only a message signal, and if you want to catch that, then what you have to do is you have to put a very high antenna. That's why you might have observed in olden days when they were just putting the antenna, normal antennas, not about this just for Doordarshan or anything. They should they'll be putting a very high antennas at villages and all, and they used to turn those antennas to catch the signal. So that is the problem. How much over height you put the antenna, that much quality signal you'll be getting. But if you are not going to mix a carrier signal with a message signal, that means if you are not using modulation, then what should be the height of the antenna to to catch that message signal? So for that we have a formula, H is equal to lambda by 4. This is the formula we are having. Lambda is the wavelength, h is the height of the antenna. So from this we find out the height of the antenna. So if you let us assume that we want to transmit a 5 kilohertz signal. I have a 5 kilohertz signal. That signal should be transmitted to the destination successfully, and I'm not going to use modulation. Modulation is not used means I'm not using a carrier signal. Only my message is traveling. Then to this we are having C is equal to F lambda formula already. So lambda is equal to C by F. If you substitute to this, we get H is equal to C by 4F. Then, as you know that C is speed of the electromagnetic wave, and it is 3 into 10 to the power of 8, and 4 into 3, this one is 5 into 10 to the power of 3. So, if you calculate this, it comes around 15 kilometer. So if you want to transmit a signal of 5 kilohertz message signal which is not having any carrier in it, carrier signal is not there. If you want to transmit this 5 kilohertz signal successfully, then your antenna should be kept at 15 kilometer height. Is it practically possible to keep an antenna at 15 kilometer height? 15 kilometer height, that much top you need to keep the antenna. Is it practically possible?
No, sir.
No, right? So 15 kilometer, just imagine, if just tell for 100 meters on the, oh, that much height will tell. 15 kilometer, that much top, your antenna should be kept. Then only you can receive this 5 kilohertz message signal. So that's why from this formula you can see that higher the frequency, what will decrease? How is H and F are related? They are inversely proportional to each other. If your frequency is increased, height will automatically decrease. For this case, I cannot change my message signal, right? Because our audibility range is only till 20 kilohertz. Just to reduce the height of the antenna, I cannot speak at gigahertz range. Right? We don't have, human beings don't have that much capability, or we cannot speak at megahertz range. If you speak at megahertz range also, we cannot uh, listen because our audibility range is only till 20 kilohertz. So what we do is this message signal will be added with a carrier signal of very high frequency, like carrier signal of megahertz and all. When you add that carrier signal, automatically the height of the antenna will be reduced. This is the reason for using modulation. Then one more thing is to avoid mixing up the signal. See, if you keep on talking and if you are transmitting only the message, see, our audibility range is even the voice range, voice frequency will be almost same, right? If 4 of us are talking together, we'll be not able to listen, right? So if all of you are talking, I cannot listen who is talking. Everyone will be talking. So it is just a mixing of signal. To avoid mixing of signal, what we will be doing is we add some carrier signal so that each voice will be separated by other voices, because all of the voices are more or less in the same frequency. But when you add this carrier frequency of higher range, there will be a separation between each messages. I mean, each voice signals. So to avoid the mixing of the signal also, we can use carrier signal. To increase the range of communication, as I told, so when the distance is far, the signal starts deteriorating. So if you are adding a carrier signal of higher strength, automatically it can transmit for a larger distance with the same energy. To allow multiplexing of a signal, see, we have limited channels. If you take one base station or a tower, we are having, let us assume that we are having a tower near BMSIT. See, that needs to cover around 6 kilometer to 10 kilometer radius. That one tower should cover 6 kilometer to 10 kilometer radius. Okay, radius. If you think about the diameter, so around 20 kilometers around it in 360-degree. So all the subscribers who are coming in that range will be connected to the same tower. So, and the channels available, wireless channels which are available in the tower will be around 260 to 300 channels. This 260 to 300 channels should be utilized by that many number of people. There'll be lakhs together persons who are accessing this that tower. So here multiplexing need to be done. That means each channel will be given to multiple users. Same channels, all of us will be using a same channel, but we are having different frequencies of carrier. The carrier will be added to that. That's why this interfacing, or sorry, the interference between the signal will not be there, because my carrier frequency is different, your carrier frequency is different. Even though both of us voice frequency might be same, but when we add a carrier frequency of different carrier frequency of different range, during that time our voice signals will not be mixed up. So we can transmit multiple signals in a single channel. So that is known as multiplexing. To allow adjustment in the bandwidth, we can adjust the bandwidths based upon if there are more number of subscribers, we can adjust the bandwidth by allowing more number of subscribers to use same channel. Then to improve the quality of reception, again, as you can transmit the signal for higher range with good quality, automatically the quality of reception will improve. So these are all the important things with respect to need of modulation. After this, there is a last topic, principle of operation of mobile phone. There we'll discuss about how these towers are connected, how actually your signal will be transmitted. So what actually happens? A few of them might be knowing what happens uh, once the signal is going out from mobile. But if someone is not knowing, it will be an interesting fact, because many of us know that only it depends upon tower. So I'm using Airtel. So I'm using Geo. It's finally where it goes. Who is going to control that? So that is one of the interesting aspect which we have. So that we'll see in the next class. Basically, this